The availability of STL files for printing RC model parts has transformed how many people get models into the air. Probably most folk that purchase commercial STL files will pass them through their slicers and then on to their printers with more than the usual waiting for the print to finish and tweaking slicer setting frustrations. A friend of mine had a shiny new set of STL files for their next exploration of the sky, found that the nose of the fuselage was not really a good fit for the spinner of their folding prop. Nothing in the parts bin either, and a long wait if it was possible to get something for China. What if you actually simply can't find a close match from any vendor anywhere? Do you abandon the project? Do you live with the extra drag? Or do you tweak the STL so that you can get into the air? My friend sent me the STL file and I started up FreeCAD and imported the mesh and had a look around. As with many commercial design, it is decidedly complex beastie. Credit due to the folk who've worked out all of this detail. However, in this case, they chose not to produce variants of the nose to fit a range of spinners. So, how reasonable is it to contemplate tweaking this particular STL? Well, we might start by assessing what kinds of changes would make a revised STL fit for purpose. In this case, the spinner was 2 millimeters smaller than the diameter of the front face of the fuselage. For a powder glider with a folding prop, this would be a serious drag. Changes would need to be blended into the remaining fuselage. I had recently explored cutting apart an STL wing to arrive at bespoke ribs and spars. It seemed like a rather nice challenge to adapt the nose STL. I would learn some more about FreeCAD, and my friend would hopefully get flying sooner. This leads on to the second question. Can it be done without compromising the structure of the fuselage? Looking at the STL, there are some mounting holes and ventilation openings that should not be corrupted. Next thing is, what kind of assumptions are we making? Well, the front face is circular. I certainly hoped it would be possible to take a simple shape, like a revolve or a cone, and apply some boolean logic to arrive at a good fit with the spinner. Now, I approach a CAD work file so that there would be minimum pain if an idea doesn't work out. As with my earlier videos, which started with an STL match, it needs to be imported and transformed into a body that can take part in a Boolean task. And you can look back over the other videos to see the details of that workflow. One of my rules, so that I can backtrack easily, is to avoid working with the initial solid body that was created. Instead, I create both a refined copy of the solid and then a simple copy of the refined body. It takes seconds, can save minutes. If I mess up, I've got something to go back to. Now, there's a question about accuracy. Doing a sketch with a revolve might get me something kind of like a cone to work with, but really I don't want the hassle of all the trig. Using the inbuilt cone primitive, I could be precise without a lot of maths. 10 millimeters seemed to be a reasonable distance to blend. As we shall see later, well, there was a bit I missed. Next, having built up the CAD entities, I saved the CAD project to a new name and went and worked on that. The first thing I noticed was getting the cutting body accurately positioned. The whole process just felt rather clunky. The next issue was getting a clean cut. In my prior work, using one body to slice apart an STL, it was critical that the STL cleanly slices to two bodies. However, given the complexity of this STL, it didn't really happen when I did the split apart. What if I created a different kind of cutting body and then used a Boolean cut? So, a bit of lateral thinking. Hey, let's create a rectangular block and subtract the cone I already have from the block. This gives me a solid body. It happens to be rather simpler to position, and actually it turned out to be successful. Now remember, this is a coffee break tweak, not a work of art. Of course it might be possible to get a better blend, but before investing in perfection, time to get the opinion that really counted. I uploaded the tweak STL to my friend for him to review and print. And here's his photos of the model he made. He was actually quite chuffed with the result, and the resulting model survived its maiden flight. What he did notice that I had not was that the lower portion of the fuselage had a slight bump to allow space for the leads to the motor. In this area, the fuselage was thinner, and so this produced an artifact in the lower fuselage. He treated it as an extra ventilation source and carried on.